Yeah, so people at the hand, can you just confirm if the font is visible? Sorry, I was late.
No problem.
Hey, so our next speaker is Lalatendu Mohanty. He's from Red Hat. He works on their container engine. He'll be talking on OpenShift, which is a platform as a service using Docker and Kubernetes. He has contributed to projects like CentOS, Fedora, and more. Please, a round of applause for Lalatendu.
Thanks. So before I start, just wanted to make sure that my fonts are visible to you guys. Is okay? Should I increase the fonts? Increase? A little bit. Okay, fine. Should be okay, right? Okay. Uh, so I'm going to talk about OpenShift. Obviously, we are talking about DevOps days, so we're talking DevOps days. So we'll talk about DevOps more. So how many people, just before I start, how many people have heard about OpenShift in this room? Some people, okay. And how many of you used it? Okay, cool. So about myself, like he said, I'm a working Red Hat software engineer. So my interests are free software and open source and distributed systems, containers. So we're here. Right? Before I start, I just wanted to set the context. So if you see, we have evolved in IT. The IT before 10 years or maybe 20 years, and now the IT is different. And why this evolution happened? Because we wanted to be more agile to meet business needs. We wanted to be more agile in terms of responding to business challenges, responding to market challenges, responding to competitors, all these things, right? So you'll see development process like we used to do. I think still people use waterfall development model, then agile, then we're talking about DevOps where it's mostly a cultural thing where operation team and developer teams kind of create a culture where they can collaborate on each other, not fight with each other, right? Not work in their own silos, but work along with them, with themselves, right? And then talking about application architecture, monolithic where you develop everything together, then you break down applications into like databases as physically separate, then front end is physically separate. Then we're talking about microservices where actually even break down individually the big service into small microservices, like small services, and so that independent team can actually take over the small piece of microservice and they can their own timeline of delivering to production, stuff like that, and independently teams can develop their stuff and the whole applications come together, right? And then in terms of infrastructure, we had physical servers and virtual servers. Then we were talking about containers, which is more lightweight than VMs. And obviously there's different factors like the return on investment and also utilization. Is better in containers, stuff like that. Like for example, if you have a physical server, and if you can run like n number of virtual machines, but you can run actually many more numbers of containers on that particular physical machine. So you're getting basically utilizing the hardware better, right? And then we used to have data center. Then people started using hosted data centers, like the big data center, but you can rent a chunk of it, or maybe something like OpenStack. Then we are talking about now the cloud providers like Google Cloud Engine and maybe like AWS and other stuff, and also like Cloud Foundry, OpenShift. So before I talk about OpenShift, so I want to talk about why we do certain things in a way. The reason is mostly about an application. So what is the requirement from modern application development? What is our expectation, and how do you fulfill that expectation using OpenShift, right? So nowadays, I mean, if you are into application development, you mostly develop it for mostly web applications, mobile applications, client service architecture, right? And it's designed for continuous delivery. So if you see our Silicon Valley unicorns, right? Netflix or Twitter, LinkedIn, and stuff like that, they have the capability of delivering anything from development to production more than 100 times a day. And that's how they meet business requirements. That's how they become agile. That's how they, taking customer feedback and basically again delivering on customer expectations, stuff like that. So that's how continuous delivery basically helps you. And I think I don't need to explain it more because people are aware about DevOps and continuous delivery here. And designed to scale up and scale down depending on the requirement. If you have an application and suddenly the traffic to that application goes up, you should be able to scale up, and it should be designed and the infrastructure should support that, right? It's a very generic thing. And also can utilize modern cloud platforms, because modern cloud platforms like AWS, Google Cloud, OpenShift and stuff like that, they help you a lot many ways. so that application developers can only focus on developing applications and not worry about the underlying infrastructure at all, right? So application developers supposed to know about application and they should focus on developing the application in a good way. And the underlying infrastructure should take care of other things which is required for business continuity and also all these things we need, scale, agility and stuff like that. So modern application development again is like we talk about microservices, continuous delivery. There are different models for continuous delivery. Something called blue-green deployment, where you have two real replicas, and you basically the part which is live, which is green, and you can basically, if you're bringing a new change, you can put in the blue, and then stuff like that. You can rotate it whenever you put it something and it works, then you can make it live. The other part you can make it again into pre-production kind of thing, right? And there is canary deployment where you can you basically only like out of 100% of a user base, you bring in a new change, and then you get the change to only 10% of your users. And then depending on the feedback, then you basically change to a region or again 20% of the users. Like Facebook does it very frequently. You can see a new feature comes in, and it's only for US people or Indian people, and then again that feature gradually goes to other countries. So it's basically phased out rollout of features. So canary deployment. And there are guidelines like 12-factor apps, which is mostly written for guidelines for how you can develop a cloud-native application. So how many people are aware of 12-factor apps in this room? Okay, not much. So you should, I think, go back and read about it. So basically, this is like whatever people experienced with their experience, like by not doing certain things, which basically stopped them from using developing cloud-native application, or the kind of challenges they face later in the life cycle of application. So all these things can be taken care of from the beginning, right? So that's 12-factor apps. I've given the link. So then OpenShift basically takes all these factors into its core. So it addresses all these things I've talked about. And how it does it, right? So this is the question. So just to give you a little bit of background about OpenShift, it's basically a container platform, it's a PaaS basically, right? Platform as a service to run containers. How we run it, we'll talk about later. Then it's a platform to deploy microservices. It's basically specially designed actually. It's very suitable for microservices. And you can choose programming languages you want. So if you are a Ruby developer, if you are a Java enterprise developer, you are a PHP developer, you don't have to, the platform basically takes care of many things. You don't have to worry about things. You can choose your programming language you want to develop your application, and the platform will support you for that. Then it's designed for continuous deployment, right? So I will talk about how it helps in that area. Self-service platform. So what does it mean, self-service? So what happens in real use cases when a developer develops an application, he needs an environment where he can deploy the application. So he then requests the operation teams to give a set of environments, right? So that's take a lot of time. So what about creating a, so operations team basically set up the OpenShift environment, and then developer, whenever he needs, he can just go there and get his environment. I mean, then there is the time of, there's a time lag between you request the operation team and get the environment, and then you just go yourself, self-service. You can just deploy application. So much of time and cultural gap basically closes that on that particular loop, right? So there's like, you just go and do your stuff. That's it. And platform as a service, like I talked about it. So the good thing about it is like, it can run on most of the infrastructure we have now. So you can have physical machines, and you can deploy OpenShift on top of it. You can have virtual infrastructure, VM, virtual machines, and you can deploy OpenShift on top of that. You can also run it on private and public clouds. So let's say public cloud, when I talk about AWS, right? You can run OpenShift in AWS. If you're an AWS user, you can run OpenShift in Google Cloud. So if you're a Google Cloud user. If you're an OpenStack user, like if you want to talk about private clouds, you can also deploy OpenShift on top of that. So yeah, that's about it. So if you have any question, you can actually interrupt in between. I mean, whenever you have the question, don't need to wait for the last slide. I mean, it's fine. Yeah. Right. Right. So then there's something called hybrid cloud concept. So when you do Google Cloud, right? Obviously you choose like you want to be on Google Cloud always. So what happens? Let's say you want to be, again, like in computer engineering, there's something called another level of interaction solves the problem. So you use OpenShift, right? And you can use OpenShift on-premise also. You can use OpenShift on-premise. You can use OpenShift on clouds, wherever you want, however you want. So you're not tied up, I would say, logged in. I don't know if it's the right word, but yeah, you have flexibility. So how does it does it? What OpenShift does, like under the hood, it uses Kubernetes and Docker. I think this is one of the greatest strength of Kubernetes, greatest strength of OpenShift. So OpenShift engineers have contributed a lot of features into Kubernetes. So they are like top 2 contributors. So basically, whatever feature, so OpenShift, this version I'm talking about is OpenShift v3. So we had 2 previous versions, OpenShift v1, v2, and they have their own container technology, own orchestration mechanism and stuff like that. Then there is a development started happening like Docker and Kubernetes there. If you are watching the container ecosystem, Kubernetes and Docker has the maximum community contribution and what is it, traction. Yeah, it's very, very popular and a lot of people contributing the innovation. And once a community starts like self-sustenance, like people are contributing and the feedback loop basically rolls in, and then you cannot stop the innovation. It basically just moves ahead. And same thing happened to OpenStack, same thing happened to Linux kernel and many other open source projects. So in V3, we use Kubernetes and Docker. So OpenShift people have, like engineers have contributed a lot of features which used to be previously OpenShift versions and then now think that should be part of Kubernetes and they basically moved it to Kubernetes. And then the other things which Kubernetes does not make sense, like Kubernetes should not provide those things, those are basically again now in OpenShift. So basically it's like a Docker, then Kubernetes and plus other things which makes it a PaaS or a container platform. So these things are like Kubernetes, there's no option to do Docker builds. And in OpenShift, there's a feature called, basically there's a project called source to image, which basically does the builds for you, right? So as a developer, you don't have to worry about the Docker or Docker file. So the developers should write the code, and the platform should take care of the other things, like I said. And so OpenShift takes care of the Docker builds and deployment, everything, right? So also the other things which is required for continuous deliveries, like integration of Jenkins. There is something called Jenkins pipeline. All these things are integrated already, and you don't have to have a separate Jenkins instance. You can run Jenkins already inside OpenShift, and then use it for other stuff. Right. So the other thing is like a fully integrated Docker registry. So what happens is it's very useful because when you are doing local development, you don't want to push the image to somewhere public. You want to have a local registry. You want to push the images there, and then again use that for your deploying the application locally. And then see if it works or not, right? That is useful. So this is where the local Docker registry comes to picture. And I'll see, I think I have a slide where I can show you a little bit about it, right? And then the other thing like networking. So in Kubernetes, you have multiple options for SDN. Now in OpenShift, you have opinionated, what OpenShift engineers think is right, they have already integrated stuff. So you just use it. They use OpenVSwitch, it's another open source project. Then integration with Docker having other third-party repositories. So if you have a local repository in your organization, you don't rely on a public repository, you can reuse it. You can reuse the other companies who are offering Docker registry, like Red Hat also offers, and other company I think offers Black Duck or something. So you can again integrate them. So it's kind of flexibility for you guys. And there are other enterprise features like quota. So if you have a project, you want to basically allocate resources and stuff like that. So that's possible. So like I talked about it, these are the things like self-service is a very important factor, and multi-language support, Java, Ruby, Python, PHP, whatever you name it. And then collaboration, because the way you develop the application in OpenShift and then again basically put it into a Git repository or source control, and everybody can reuse them in their again and on and OpenShift environments. It's like increases the collaboration. And web scale, like I talked about, right? Platform PaaS should be able to support web scale. Whenever you need, you should be able to scale up the things like horizontal scaling and vertical scaling, and supports both. OpenShift is a thing, it's a project supports obviously horizontal scaling at this, but you can do vertical scaling also on the infrastructure side. It is open source and enterprise grade because it uses a lot of enterprise components like Kubernetes, Red Hat Enterprise Linux. You can also run it on other open source distributions, but for enterprise side of things. So now you have application source code, and OpenShift basically deploys it into OpenShift. And how does it happen? How does the build happen? So the build can happen in basically there are three options to do the build. One is it can directly create a Docker container out of a source code. A second, you can actually create a YML file, OpenShift template, which would have all the information. You can just deploy the template, and it can deploy the application. Or you can actually use Docker images to deploy applications. So for example, you have an application in Docker Hub, like the example I have given here, Kubernetes and guestbook. You can directly do OC. OC is the OpenShift binary, client binary. And you can just use OC new app and the Docker image name, and it can download and actually it will push to the local registry for caching, because the next time you build it, it won't pull from the Docker Hub. Then again, it can deploy to the OpenShift. I'll gonna demo this one for you. Right? So when building Docker images, so how does OpenShift recognizes from source code how does it do it? So it has some predefined builder images. So for example, if you have Ruby code, so it has already a layered image for OpenShift origin, which is the community version based on CentOS images. So CentOS Ruby image is already there. So you are developing a Ruby application. So when you basically point it to a source code which is Ruby code, it detects it. I will talk about how it detects it. Then once it detects it, what it does a build, it basically compiles the source code and injects into that builder image. And then that's how it basically creates the image for you. So you can also define your custom builder. So let's say you don't want CentOS based Ruby builder images. You can do you can change it to Ubuntu or whatever distributions you want. So this is the table how it detects. So for example, it finds at the root of the directory, finds rec file or gem file. Then it considers a Ruby code for J2E and stuff like that, and Node.js. So this is the table for Python requirement.txt or setup.py. Any question? Yeah, go ahead. Web application or?
Like if you take JE, right?
Right.
So it could be a standalone application or it could be a web application. It might have to be in Tomcat. What is this image about?
I mean, it can be a multiple part, right? You're talking about multiple containers kind of thing, right?
No, even in this Java application that I have, might be it's a web application. It would detect that and build a appropriate image, is it? Docker image for that particular thing. Will it do that?
Yeah, it do that. So for example, if you have a Java code, right? So what it does is like a talk. So it can actually reuse for Maven. It can reuse Maven and build ultimately the var or Java file, and then inject it into the Docker container.
Okay.
But obviously, there are things like port indirection and all these things. Those things we have to change in the build config. There is a way you can define that in the source code. You have to basically read it and then put it. Otherwise, you can, after building it, you can basically change the build config, which is basically a YML, which you can basically put all the information. That's similar to how you put in Kubernetes. Yeah.
Okay, I think you're trying to sell OpenShift here, but why haven't you done a comparison of other solutions out in the market? Because I am not sure technical only is going to help you. You have IBM Bluemix, you have AWS, you have a whole lot of set of vendors who are competitors.
Right.
Okay. So technical, I don't know. I'm a non-techie. Okay. So tools doesn't make sense to me. Someone said that if you have a hammer, every problem seems to be a nail to you, and that's what the approach is going here. Okay. So why should I use OpenShift? You need to give me a business case as to why.
Right. So this talk is mostly technical, honestly. This is not a marketing talk. And I'm talking, if you see, there is no logos of any, I mean, even if I'm from some company, right, I don't put logo here because it's mostly about technical. And I think the biggest, the last slide I have, okay, the last slide, I can go to the last slide if you want directly now. So this is the advantage I see, the most advantage. So I talked about it in the beginning, that when a community becomes vibrant and there is a lot of external contribution happens, not from individual companies, and people start contributing, then you cannot stop the community. It basically grows up. Cloud Foundry, right? So this is where I talked about, right, initially. So if you see container space, the orchestration, and Cloud Foundry would be a good cloud. I'm not saying it's bad. It's definitely a good one. I don't, so. Right. So if you talk from technical point of view, I'll talk about only technical point of view. Cloud Foundry have their own orchestration engine, not Kubernetes, and even they used to use their own container engine. I think they are moving to Docker. I think, yeah. So, but I think the amount, if you see the amount of traction Kubernetes has gotten recently in last 1 year, and I don't think anybody, I mean, like Docker, right? If you want to create a new container project, it's very difficult to basically compete with Docker because there's like more than 1,500 contributions, or like it's growing, and a lot of external contributors, not for some company contributing. It's basically individual contributors, community, open source people are contributing, maybe small piece of code, but that's everybody when contributes becomes large. That's a gray. That's not white and black. We can talk about after my talk. Let's focus on this. I can talk to you, about it. It's not easy. I mean, I don't know if you history know about OpenStack. A lot of projects come around OpenStack, and now none of them have survived. Only OpenStack has survived. So, anyway, and that's my personal opinion.
Yeah, excuse me.
Sir.
One question about that. Building the images, right? Docker images.
Right.
See, in our organizations, we have, shell, and within that, Python being called. It's not a standardized, fully Python model. What is the approach you would recommend?
Yeah, for that, I think you have to do little bit changes to the application.
Okay, convert everything to Python and then use. This. Okay, thanks.
Because so I think you have to assume certain things in a set so that you can basically then take the assumption ahead, right? Abstract it.
Okay.
If you are saying this OpenShift is multilingual or supports multiple language,
right.
So what exactly you mean?
I mean, you can run applications written in multiple languages.
But that's a concept of containers, right?
Containers, yes.
Means for me, you cannot directly run a Java program.
That's a typical characteristic of a PaaS, platform as a service. If you see any PaaS, would support multiple languages, the one.
Okay, so it's, you mean actually you can run any application in which is containerized or which is we are packaging in container way.
Correct. Yeah.
It's not like Kubernetes, like where you can schedule a program, scheduling different things other than containers.
It's basically based on Kubernetes, but mostly geared towards microservices using containers like Docker and Kubernetes. I mean, you can do stuff. So again, if you see the underlying infrastructure is mostly based on Kubernetes. So if whatever you can do with Kubernetes, you can do it in OpenShift because the inside infrastructure is exactly the same.
Okay, fine.
Yeah, fine. But my point is like I'm talking about mostly from application point of view when you deploy application from it, right? Yeah.
Hi.
Yeah.
Here. So do you have anything for Angular or React where Bower is getting detected?
I think Angular there is something, I'm not sure, I have to check. Okay. I think Angular is there, yeah. Angular JS. No. Yeah, it's very different because Heroku is not an open source project. Is it an open source project? So build packs is similar to what we have in Docker, isn't it? S2I, right? I don't know if build packs is open source. I'm not sure. Is it open source? Okay, but it's based on completely Docker. I don't know if build packs is completely based on Docker or not. So S2I is completely based on Docker. I've used Heroku a little bit. So Heroku obviously is a good platform, but it's not open source. So you cannot install it on-premise. Can you? I don't think so.
Sorry,
you cannot do on-premise installation of Heroku, right?
No, Heroku is hosted PaaS.
Only hosted PaaS, right?
Very similar to your Elastic Beanstalk or any
Right.
other services out there.
Right.
But you can, I mean, build packs are not like very specific to Heroku.
Right.
Build
right.
packs helps you follow the 12-factor app to build packages, which does these code detection and your tarball images, I mean, creations. So when I just looked into the OCI, I mean, the S2I repository.
Yeah.
So I just wanted, and realized it was very similar to build packs.
But it's based on completely on Docker build.
Yes.
Yeah.
So it was reinvented, like it was written from
It's
scratch.
not reinvented. We are using Docker again because you see our unit, the basic units are Docker and Kubernetes. The advantage of doing that is because when Docker community innovates, right, you can reuse this stuff in OpenShift. Basically, you see there are a lot of innovation coming together. Innovation from OpenShift community, innovation from Docker community, innovation from Kubernetes community. So this is basically they're like independent parts where you can just get the latest from the Docker community, right? Okay. So before I go to further, I think I'll do a little bit of demo here. Then we can talk about other stuff. So how do I run OpenShift on my laptop? There are two ways. The community version, which is OpenShift origin, the OC is a binary. If you see go to their project and the releases, there would be OC binary. You just grab the binary and download it on a laptop. And if you already have a Docker daemon running there, that can reuse it, or you can actually use Docker machine to basically create a Docker daemon for you, and then you do OC cluster up. What it does is basically downloads OpenShift, which are containerized again. It download 4 to 5 OpenShift containers, and then basically provisions them to give you a OpenShift single node cluster so that you can basically develop on your laptop. So to do that, what I have done is in DigitalOcean I have created this CentOS 2 GB a virtual machine, right, cloud. Then I have basically written a script which basically downloads the release OC client and basically does a OC cluster for me. If you see the first line, I do insecure registry. So that's where OpenShift basically hosts a Docker registry. It's an insecure registry. It needs to be added into the configuration so that it can reuse the Docker registry. So that's what I'm doing here. So it can, even if you don't do that, if you do OC cluster, it will tell you to basically do that. So again, you can redo that stuff. So I'm just gonna run it. So now it will basically, it's downloading the binary now. It will extract, and then it will run OC cluster up for me, and then it will download the OpenShift Docker images. Let's see how much time it takes. It takes for me around less than 1 minute to set it up. And while it does it, so we have other mechanism called container development, which is people who want to have OpenShift Enterprise, which is called OpenShift container platform now. So you want to have the enterprise bits running on your laptop. So that's another way. I'll talk about it at the end of the slide. Okay, so it's already had downloaded. It's doing the configuration. So this is because I'm running it in a public cloud. It would be there will be two ways of accessing OpenShift. One is web console and one is the client, basically the command line. So because I'm running it in a public cloud, the web console would be available to you also. I mean, it's like publicly available. And after this demo, I'll delete it. I'll just destroy the droplet. So yeah, it's already done. So if you see here, this is the, so there are two ways. The inside here, I would say this directory, I can go there. Sorry. So here you can see the OC binary. You can see OC login -u developer. So it would be logged in already. And if I go to, I can go to web. And try to access it. And I'm using the OpenShift origin, which is the community version from the So developer. Okay, so you can basically create your projects. So projects are like namespaces. So I'll maybe create a new project called demo one, and then say sorry demo one and create. So if you see here, there's already a couple of templates which are already exported. So you can actually click on these things and you can run the application. For example, I can just click on the Jenkins ephemeral and can run Jenkins. But I will try to deploy applications like I said, we can deploy it using source code. We can deploy it using the template. We can also deploy it using the command line, the Docker Hub, some Docker image, right? So first, what I'll do is I'll create a new application. I want to deploy something called Node.js. So Node.js 4, and I have this demo application which I'll copy and then go here, say Node.js demo, then say create. So now application created, continue. So what's happening is now what it does is checks out the git clone code, and now it's doing a local build, a Docker build. And if I want to see the log, I can click here, and there's something called follow button here. I don't know where it is. It takes some time, should be like less than 1 minute. So you can see what's happening here. This is a very simple Node.js application, just you get a web page at the end of it. Okay, so meantime it's builds. What you can do, the other example I told you about, I can use any Docker images to deploy application, I'll do that. Sorry. Okay, so it's currently in my project namespace. What I'll do is OC new app and say Kubernetes / guestbook. Oh, sorry, I have to. Okay, so let's see what happens to that. It's already all created. So there, see. Okay, something called follow button here. You can see it's downloading the Docker images. And now it's already downloaded, it built it. Then it's currently pushing to the local Docker registry OpenShift has. Okay, push successful. If you go to overview now. Okay, so the terminology is the same, pods, which is same in Kubernetes. So now it's basically deploy one pod of that application, and the endpoint is here. It's already created a route. Oh, I think I have to create a route. It's not there. I think it takes this time, I think. Let's go back. Interesting. So it's actually it's by default. If you see the service port is 8080, it's already done that. So mine it should work. I don't know why it's not working. Let me get another route. See, its target port is mapping there 8080. So 8080 is the default port. So if you click on 8080, by default it should, so in the browser 8080 is default port. So you can see the application is here, right? Yeah, it's deployed basically. The other things like it supports, let's go back and see, show you little other things. So it took, I think, yeah, that route started working. So now you can do stuff what you do in Kubernetes, like replicas. You can increase the replicas and stuff like that. And using GUI, it's very simple. So if I click here, if you want to horizontally scale, right? If I just click here, so it will scale up. If I scale down, if I want to scale down, you can just scale down. You can use the command line tools also for that. So if you see now, so pods, you can see this pod is already deployed and the other things are running. It will be done in some time. And this is one deployment, right? 4 replicas. So this is how we can see. So you can see other things like you can do persistent storage, like Docker containers are ephemeral in nature, so you want to add persistent storage, you can add that. So before we go to details, we'll go and see what happened to our other the command line what I basically deployed, the Kubernetes guestbook. See, the Kubernetes guestbook is here. It also running one pod. I have to create a create route. So let me create a route. It's basically mapping here the port. And if I do this, okay, maybe it's because I'm running it from a cell phone. It's taking time because I'm using my cell phone's 4G internet.
Lalatendu?
Yeah.
Sorry, here. On the other side. Hello.
Oh, sorry. The slide is so strong.
Sorry.
Yeah.
So we are out of time.
Okay.
Can you start wrapping up?
Okay, sure.
I think you still have like 2-3 minutes of the time.
Okay. So I'll go to the content. So other things which normally pass basically gives users like auto scaling. Like I was doing auto scaling, show you guys. HA proxy, if you want to integrate external service, like if you have external database, you want to connect it. And then routing, how does you can actually put your domain and route so that you can basically have a secure route or unsecure route. Container health check using readiness probe and stuff like that, the way Kubernetes provides it. And you can have logging infrastructure extra, integrated it to it, like I talked about Elasticsearch, Fluentd, and Kibana. There is Quota. What is there for developers? It's integrated with, now it's currently integrated with Eclipse IDE. So there is something called OpenShift adapter in Eclipse. Even if you use Eclipse, the open source one, the community edition, and you can, Java developers can directly develop applications there and deploy it to OpenShift running somewhere. You can remotely connect. And then Jenkins is strongly integrated in OpenShift. So for example, like I showed you Jenkins ephemeral, you can run it there and then again integrate your CI stuff inside OpenShift to do continuous delivery. Ability to move from QA stage production, you can have different namespaces for QA stage production. There are multiple ways of doing it. Two of the famous models, what people do is either they have multiple instances of same OpenShift or have the same instance have different namespaces. And you can have QA, whatever the pipeline you choose, right? QA stage production. And you can move stuff from one way to other. So this is a new feature came in, Jenkins pipeline. It's called OpenShift pipeline now. It's based on Jenkins pipeline. You can actually define, if you have used it, you have to create a Jenkins file and then define the stages. And then OpenShift basically reads it and basically show you in the web GUI, you can see the stages complete and how much time it takes. And if you see authorization to send it to production, so it will wait for your interruption. You say click, okay, push to production, then it goes to production. The other offerings, there are a lot of variety of OpenShift Origin, which is the community edition, which I used, OpenShift Origin. And there is OpenShift Online, which is a hosted solution. And they have a marketplace also. If you want to use somebody else's product, which is supported by them, you can use that. Something like monitoring, you can use something called dog. I just forgot the name. Yeah, Datadog, right. So then you can use Datadog for monitoring, stuff like that. And there's something OpenShift dedicated, which you can deploy on other clouds, like AWS, Google Cloud Platform. And there is OpenShift Container Platform for on-premise. So this is another way to get OpenShift on your laptop. You can actually do Vagrant up. Actually, I can show you if I have time. I don't know. So,
Lalatendu, we are almost out of time. We have lightning talk session again today and the open spaces, so we can cover that.
Okay.
In there.
So yeah, so you can do Vagrant up and you can get your setup. So some people use the Vagrant workflow, which is really helpful for them. So competitive edge, I talked about it. I think this is where I like OpenShift because it reuses the popular the OpenShift the open source parts, and OpenShift engineers contribute to there itself for the features. So it basically helps the whole of open source ecosystem rather than reinventing the wheel. I think that's the biggest competitive edge I can see, and it can evolve. This edge can actually evolve, help it evolve into a very, improve it and gradually become one of the best platforms, I would say. That's it. Thanks, guys.
Thanks, Lalatendu.